Howdy students, we are getting started with lesson 4-4, which is multiply a decimal and a whole number. We're going to take what we learned last time and just do it a little bit more today, so things will get a little more complex, but we can do it. Here is our learning goal. I can multiply a decimal by a whole number. If you don't have your workbook or a pencil, I want you to go grab your workbook and a pencil, and then we are on page 141 with our solve and share. Okie dokie, let's go ahead and read our solve and share. I'm going to pause it, let you guys give it a try, and then we will talk about it all together. A car travels 1 15/100 kilometers in 1 minute. If it travels at a constant speed, so it's not speeding up or slowing down, it's going the same speed, how far will it travel in 3 minutes? In 5 minutes? Solve this problem any way you choose. So go ahead and pause the video right here, give it a try, and then we'll talk about it all together. Yokie dokie, let's go. So we have our 1 15/100 kilometers in 1 minute. So now I need to see how far it would travel in 3 minutes and then in 5 minutes. So last time we talked about using repeated addition and multiplication to kind of like check our answers. I'm going to go ahead and just dive into our multiplication. So if 1 15/100 kilometers is in 1 minute, then for 3 minutes, I would just have to multiply it by 3. And what you're going to notice is my decimals are not lined up. With our addition, so if I were to use my repeated addition, like I said, we just weren't going to do, I would have to line them all up and keep my decimal in the exact same spot. But multiplication is different. I ignore my decimal, you still put it there, and then we pay attention to it at the end. So now we're just going to multiply like normal. So I need to take my 3 times my 5, and I'm going to get 15. Circle it, don't forget it. 3 times 1, well that's 3, plus 1 more is 4, and 3 times 1 is 3. So we have 345. Well, even if you just think about this for a little bit, 345 kilometers is way too big to go from basically 1 kilometer. You know, something's a little bit off. So what we have to pay attention to is how many numbers we have to the right of our decimal. So up here in my factors, if I have my decimal right here, if I look to the right, I have 1, 2 in my first factor. Now, if I look down here, do I have any numbers to the right of my 3? I do not. So then I'm going to come down here. I have 1, 2, and my decimal is going to fill in right after it. So what I get is 3 45/100. Well, if you think about this, if this is about 1 times 3, you're going to get about 3. And really, we have 15/100 left over. So if I add 15/100 3 times, I get 45/100. So if you want to see it with the 5, 10, 15 addition, we get the same answer, which is good because that means we did our multiplication right. Okay, so this would be 3 45/100 kilometers in 3 minutes. So let's try it for our 5 minutes. So I'm going to ignore remember my decimal would be here at the end of my 5 because it's just a whole number. And I don't line them up when I'm multiplying. I just put my numbers in. I put the longer digits on top, my shorter digits on the bottom, and then multiply. So 5 times 5 is 25. Circle it, don't forget it. 5 times 1 is 5, plus 2 more is 7. 5 times 1 is 5. So then now you're looking at this and you're like, Miss Collins, 575? That's crazy. That's way too many. Well, that's because we haven't checked how many digits we have to the right of our decimal point in our products. So I have my decimal point here. I've got a 1 and a 5. And then down here, do I have any numbers to the right of my 5? Nope, I don't. So then I need to go 1, 2, and plug in my decimal. And so our answer is 5 75/100. And if I took 1 times about 5, I would get 5. So an estimated answer can help you make sure that your decimal multiplication makes sense. Because if you get that decimal in the wrong spot, if I had it here and it was 57, and I was like, well, 1 times about 5 is not 57, I would know I put my decimal in the wrong spot. Okie dokie, let's go try or look at our visual learning bridge and then try a couple. Okay, So to raise money for a charity, 15 cents was collected from every ticket sold to a Lions baseball game. If you bought 12 tickets, how much money would go to charity? So you can multiply 15 hundredths times 12 by thinking about 15 times 12 and using place value patterns. So let's see how they did that. One way, that repeated addition. We're going to be moving away from this way. It's kind of a nice little security blanket because you guys did so great in topic 2 with adding our decimals, but we need to move on, right? We need to move on to our multiplication. So then now, first multiply as you regularly would with whole numbers, 12 times 15. So they did 5 times 2 is 10. They didn't circle it. Miss Collins would say to circle it. 5 times 1 is 5, plus 1 more is 6. We got their zero in there. And I'm thinking they should have their smiley face. 0. Okay, and then 1 times 2 would be 2. 1 times 1 is 1. And then what they did is add them together. 0 plus 0 is 0. 6 plus 2 is 8. And then they had 1. So 180 is your answer over there. But then you have to use number sense, or Miss Collins' little trick, to place the decimal point. Well, if you come up here, 1, 2 numbers to the right of the decimal there. We had 0 and 15 hundredths. My 12, the decimal's at the end of the whole number. So do I have any numbers to the right? No, I don't. So then I'm going to come down here and I go 1, 2, and I fill it in. So I have 1 and 80 hundredths. Our digits are totally the same though. I want you to notice that, which I think you guys did. Okie dokie. Let's practice a couple of problems. See how we do. This is kind of itsy bitsy, so what I might have to do is rewrite them a little bigger. Okay, so we're gonna go ahead and start with our number 3. It says 9 and 8/10 times 2. I'll write it a little bigger right next door. So I'm going to ignore my decimal point and just multiply like it's 98 times 2 and then worry about the decimal at the end. Again, my decimal with my whole number is at the end of the whole number. You don't really need to have it there because you don't have any decimal parts over here, any digits, but if that helps you understand it a little better, you can put it there. So 2 times 8 is 16. Circle your 1, bring it down. 2 times 9 is 18, plus 1 more would be 19. And then what you have to check, so this is 9.8, that's almost 10. 10 times 2 would be about 20. If I look at this, 196, you're probably like, Miss Collins, it's not gonna work. So remember, what we have to do is use our number sense. Well, so where would if it's about 20, my decimal's probably gonna go right after my 19, right? But if that is a little bit tricky for you, you can also come up to your factors and use kind of a little hack. So you can circle the numbers individually that you have to the right of the decimal. So decimal to the right, only 1 up there. Are there any numbers over here? So then we circle our 1 and we fill in our decimal, and it was the same as with our number sense. It's 19 and 6/10. Okie dokie, let's give it another try. So why don't we try number 4, which says 67 hundredths times 8. I think. Yeah. Okay, so I'm going to ignore my decimal for the start of this, and then I'm just going to multiply through. So 8 times 7 is 56. So I bring my 5 up here, circle it, 6 comes down below. 6 times 8 is 48, and then I need to add 5 more to that. So 49, 50, 51, 52, 53. So my next 5 comes up here, circle it. My 3 comes down below. Now 8 times 0 is just 0. Plus 5, we have 536. Well, that seems like it might be a little too big, right? I know my 67 hundredths, well, that's close to about half, or 5/10 or 50 hundredths. So half of 8 would be about 4. That doesn't seem to make sense. So I got to use my number sense. I have to use my hack to make sure that I'm getting the decimal in the right spot. So I can circle my 7 because that's to the right of the decimal, my 6, And I don't have any numbers to the right of the decimal over here. So I'm going to come down here, 1, 2, and plug in my new decimal. And so my final answer is going to be 5 and 3600. Sorry, let me rewrite that. 5 and 3600. So like I said, our answer would be about half of 8. Well, half of 8's 4, so that's really close. 5 and 3600 is really close to my estimated guess. Okay, I'm gonna have you guys try one of these on your own, and then we will talk about it all together. So why don't you give number, oh, all those are double, ooh, I'm gonna do one more because we've got some double digits now, and we haven't had that before. So I lied to you, I'm sorry, I got a couple more minutes. Okie dokie, so we're going to do 34 times 5 and 3/10. Okay, and so you'll notice with my decimal on 34, it would be after the 4 because it's a whole number. And my 5, I have it between my 5 and my 3. I don't have to line up my decimals when I am multiplying. When I'm multiplying, what is addition and subtraction? You have to line them up. With this one, you don't. So I'm just going to multiply through like normal. 3 times 4 is 12. 3 times 3 is 9, plus 1 more is 10. And then I am moving on to 0 hero. You thought he was gone, but he's back. So we put 0 hero down here, put your smiley face in. I think only a couple of you do it, and that's okay. And then you crisscross out the number that you already used and crisscross out the carryover number that you already used. So now we're ready to multiply our 5 just like we did our 3. We did the 3 times the 1's place times the 10's place. So now it's time to do our 5 times the 1's place. So 5 times 4 is 20. My 0 comes down. 5 times 3 is 15, plus 2 more, 16, 17. And now I need to add them together. 2 plus a smiley face is just 2. Just kidding. 2 plus 0 is just 2. 0 and 0 is 0. 7 plus 1 is 8. And then we have our 1. Okay, so what I need to pay attention to now is how many numbers I have to the right of my decimal up here. So just because I crossed this off, that's just our method with multiplying. So it doesn't mean that number doesn't count anymore. This number definitely still counts. So I have a 3/10 here. Do I have any numbers to the right of a decimal point up here? I don't. So I'm going to circle one of my numbers, plug in my decimal point, and my answer to number 5 is 180 and 2/10. Now, if you wanted to check this with a little bit of estimation, you could have about 30 times about 5. Well, 3 times 5, that's 15 plus a 0, we'd have about 150. Well, I rounded down with both of them, so 180 is pretty close to our 150 estimated answer. Okay, now I'm going to give you one to try and see how you do. Why don't you guys take a look at number 6? So this is 4 and 6/10 times 21. Go ahead and give that a try, and then we will talk about number 6. Please remind me in group. Nice job, guys.